All right, so in this, well, today we're going to look at section 8.3, which is dealing with percentile, box plot, and outliers. So here we're going to talk about how to locate a data value that is in a certain percentile given, okay? And then we'll also find out what number corresponds to a given percentile. And also we'll look at the 5-number summary, and that also deals with percentiles as well. And from a 5-number summary, we can construct what they call a box and whisker plot. And also with the box and whisker plot, we can also detect outliers, which is what we'll look at. All right, so first we'll look at how to convert a given number to a percentile. And here is the box, well, the definition of a percentile. If we say that the number y has a rank of the p percentile, what that means here is this: p% of the numerical data are less than what y is, okay? And percentiles are used pretty much when they're dealing with test scores. So when you take some type of standardized test, like an ACT or SAT test, usually they will have something called a percentile with that raw score. And what that percentile means is this: out of all the students that took that test, the same test that you took, let's say you were in the 84th percentile. What that means is 84% of those students who took the same test you did scored lower than you. Okay, that's what percentile means.
I'll say for like GPA, usually a lot, like the something percentile of the class.
Mm-hmm. Yeah. Okay. And now the orange box gives you the procedure how to find the percentile. And let's say you're given some value of y, and you want to find out what that percentile is for that value. The first step is to make sure that your numerical values are from lowest to highest, least to greatest. And then number 2, you want to count the number of observations that are less than that data value. And then step number 3 is to round the decimal number of k divided by n. That's the number of observations that are less than that value divided by the total number of observations, n, times 100. And we're going to round to the nearest whole number to obtain what p is. Okay, so that means in step number 4, that value, or that data value y, is in the p percentile. Okay. So in this example here, here are the scores for 8th graders on a 2009 NAEP test for data analysis, statistics, and probability. And here, let's say we want to find the score, the percentile of the score 294. That's in table 8.9. And here's that table. As you can see here, these are all the average scores for each state. All right, so here, following that approach, as you can see, the numbers are already in order from the lowest to the highest, okay? Because if they weren't, you have to put those data values in order from least to greatest. That's step number 1. Number 2, we have 50 observations. And I might need to go back to this slide just so you can see. Here's 294. Actually, there are two states with 294, but I'm going to use this one right here, the 294 that I have circled here. Now, we want to count how many are less than 294. How many states, how many observations have scores less than 294? In this case, that first column, there's 10. The next column, that's another 10 for 20. And this next column, that's another 10, that's 30. Then 31, 32, 33, 34, 35, 36, 37. So here we have 37 observations that are less than 294. Okay. 37 of those observations are less than 294. So here, the number of observations less than 294, that's 37, divided by the total number of observations, that's 50 times 100. Now here, if we do 37 divided by 50 times 100, you'll get 74. And here it is already a whole number in this case. So we won't need to round to the nearest whole number because it's already a whole number. And then for 294, that score is in the 74th percentile. Okay. So that's how we find what our percentile is going to be for this particular problem.
Hey, Doctor, what
Yes.
is the important order? How do you organize a staggering amount of numbers like that? Like 7 work or
I
try
was,
and organize the data?
you know, if you had a large number of data values like the one that I just showed you, I would suggest try to enter all those numbers in Excel, because Microsoft Excel, it will sort that data set for you from least to greatest. That would be my suggestion. Okay. Any other questions?
Excuse me, you said, step 4, what is the one for Pennsylvania and Montana? I guess you have to go back.
Yeah, because they both have 294,
Okay.
as you can see. Okay. Any other questions? Okay. All right, now let's take a look at problem number 24. And this is in the textbook, where the given data are from cost and cents to print 1 page of text for 20 printers. Okay, so these are the numbers here. And the good thing about this data set here, it is already in numerical order from least to greatest. Okay, and they're doing this column by column. So here we're going to find the percentile corresponding to 5.3. Okay. So for 5.3, here's 5.3 right here. We need to count how many data values are less than 5.3. They're 12. Okay. So here, this column adds up to 10, then 11 and 12. Okay. So there are 12 data values that are less than 5.3. So the percentile for that, of course, would be equal to, and I'm going to go ahead and write this out. That's the number of values that are less than, in this case, 5.3, all divided by the total number. So in this case here, and that's multiplied by 100. Don't want to forget that. So we just said that there were 12 data values that were less than 5.3. So that's going to be 12 divided by, and in this case, the total number of data values that we had was 20. And that's multiplied by 100. So in this case, if I do 12 divided by 20 times 100, what would I get? It'd be 60. Okay. So here, 5.3, this data value, 5.3, is in the 60th percentile. The 60th percentile. Okay. All right, any questions on part A? Okay. Now part B is finding the percentile corresponding to 4.0. All right, so now looking at this data set, here's 4.0. How many numbers, how many data values are less than 4.0? This time is 9. So in this case, this is equal to the 9 data values that are less than that divided by 20 times 100. Okay, so it'll be 45 here. So here, the percentile for 4.0 means that this is in the 45th percentile. And what that means is this: 45% of the cost for printing 1 page of text are less than 4.0. All right, and finally, part C, the percentile corresponding to 3.3. Now this time, how many data values are less than 3.3? It'll be 4, because here's 3.3, and we got 4 data values that are less than 3.3. So to find that percentile, would take 4 divided by 20 times 100. That's going to be how much? That'll be 20. Okay. So that 3.3 is ranked as the 20th percentile. So it'd be 20% of the cost for printing 1 page of text is going to be less than 3.3. Well, less than 3.3. Okay, any questions about finding the percentile for a specified data value? Okay. All right, let's take a look at this one. This is on page 472, problem number 12. And it says here, if a 20 percentile wage is $23,000, then 20% of workers in that occupation earn less than $23,000. and 80% of workers in that occupation earn $23,000 or more. The table shows the percentile wages for elementary school teachers, excluding special education teachers. And here is that table with their corresponding percentile. So here we're going to use this table from the Bureau of Labor Statistics to answer this question. What is the 25th percentile wage for elementary school teachers? How much? 40,850. Yes, we just get that straight from the table. So part A, that's just straight from the table. 25th percentile is $40,850. Now part B, what percentage of elementary school teachers earn $33,830 or more? How much? Yeah, 90%. How did we get 90%? Here we go. Because it says that the 10th percentile, that dollar amount is in the 10th percentile. That means 10% earned less than the $33,830, which means, this, if that's 100% minus 10%, it'll just be 90%. That means 90% earned $33,830 or more. Okay. Questions about part B? Oh, here's the 10th percentile means, yeah, it's up here. Okay, because that corresponds to the 10th percentile. Okay. And now, and for part C, what percentage of elementary school teachers earn less than $63,600? Well, here's 63,600. What percentile is that in? That's 75th percentile. This means 75%. 75% of those elementary school teachers earn less than $63,600. Yes.
Where is the number accounted for? Like, in the whole less than an equal, and equal to or greater than equal to, where is it accounted for? Because I was curious, does that mean 75% are less or 74? Because it's asking earn less than 63,600, not how many earn exactly 63,600.
It's just on a percentage. So it's just on the percentage. It's not asking for how many. Okay.
Yeah, but where's the people who make that accounted for?
Good question. Where is it? Where are they accounted for?
Being clear, I'm sorry. Because in the main table, when we were learning how to find the percentile, you didn't count the actual number itself, you counted underneath it, right?
Mm-hmm.
Well, if it's not counting teachers that make 63,600, wouldn't it be a lesser percentile, hypothetically?
Probably not, because they're saying the 75th percentile is this. And I think they're using this as a line, as a number to show that this is the 75th percentile, meaning 75% of the elementary school teachers made less than that.
Okay, so it's accounted for on the plus side, not on the less side.
Right. Mm-hmm.
Because yeah, in B it says earn that or
Mm-hmm.
that.
Yeah.
Okay.
because the remaining 25% earn this amount or more.
Okay.
Yeah.
That makes sense, sorry.
Okay, I understand. All right, any other questions or clarifications about percentiles? Okay. Okay, let me skip a few slides that deal with this graph here. I'm gonna skip over those. And by the way, this deals with BMI. And I just go right into this. Here you're given a percentile. Now we want to find the data value that corresponds to that percentile. We want the data value that corresponds to that given percentile. Okay? So here we're given let's say we're given a percentile, let's say the 40th percentile. We want to know the score or the data value that is in that particular percentile. So here in this orange box, you'll see the procedure for doing that. Okay? So the first step would be to, again, make sure your data values are in numerical order from least to greatest. That's number one. And then number two, you're given the percentile. We're going to let I equal to this formula, P divided by 100 multiplied by N. N is the number of data values. So P is the percentile over 100, because percent means that number over 100. Now, in step number 3, this is going to be very important, because if your I, after using this formula, if that I is a whole number, then in this case, you have to take the average of x sub I plus the number after that, okay? The data value that the position that is in plus the next number. And we'll do an example of that in a few minutes to explain all this. And you're going to take the average of those two and divide by 2.
What's I standing for again?
What was that again?
What is I standing for again? It doesn't say what
It's the
I-
location of that data value.
Okay.
Okay. It's a location of that data value. So here, let's say when I compute I, for example, I came up with I being equal to 6, which is a whole number. So I have to take the data value that is in the 6th position and the 7th position. And those two data values will be added together and divided by 2. However, if your I does not come out to be a whole number, then you're going to round upward to the nearest whole number. So like, for example, let's say your I came out to be 8.2. You have to round up.
So that means it's odd, the number of things. is odd.
Yeah.
These are the same rules for average.
Yeah. Find the median. So your I was like 8.2, you have to round up to 9. Okay. Because you have to round upward to the nearest whole number. And then find the position that data value is in. And that will be the data value that represents that particular percentile. So on this next slide is an example of how that's done. Well, here's a couple of examples. Let's say in part A, we got those data values. We want to find the 20th percentile of those numbers. And in part B, you got another data set. We're going to find the 40th percentile from that data set. Okay, let's start with part A. Here we got 12 numbers. That means N is going to be equal to 12. And then second, starting with, well, here's step number one. You have to put the data set in numerical order, as you see here. That's 2, 4, 8, 10, 15, 15, 16, 17, 19, 20, 22, and 24. So that data set is in numerical order from the smallest to the largest. Now, step number two. We're finding the 20th percentile. So it's going to be I is equal to P over 100 times N. So I is representing the location here. So, and P is 20, that's the 20th percentile. So it'll be 20 divided by 100 times 12, which will give you 2.4. And here, 2.4 is not a whole number. So that means we need to round this 2.4 up to 3. Okay. Now, that represents the third number in that sorted data set. So we need to locate the third number in that data set. And in this case, I'm going to go back here. Here's the first, the second, and the third. That's the third data set, data value, which is 8. So here, the number 8 is the value that represents the 20th percentile. Okay. Questions on that part A? Questions on that? All right, now part B, we have 15 numbers. So here N is 15. And here's the ordered list from least to greatest. So those data values were placed in numerical order. And then step number 2 is using this formula, I is equal to P over 100 times N, to find the location of the data value that's in the 40th percentile. So your P is 40 because we're looking for the 40th percentile. So that's 40 divided by 100 times 15. This ended up being 6. So here in this case, we got a whole number. So not only do we need to look at the data value that's in the 6th position, we have to look at the data value that's in the 7th position and take the average of those two, okay? Because it's a whole number, we take the 6th number and the next number after it. So here, if you look at this ordered list, we got the 12, that's your 6th number in this data set. And then the 7th number in this data set is 14. So we add 12 and 14 together and take the average of it, divide by 2. That would give you 13.
So the answer doesn't necessarily have to be represented in the set.
Right. So here, the number 13 is your 40th, is the number that represents the 40th percentile. Okay. So that's how you do that particular problem. All right, any questions about example 35? Okay. All right, take a look at, now this is a continuation of problem number 24. Okay, because in the homework, they're combining that particular problem. The first 3, we had to find the percentile for each one. The last 3, you have to find the data value that represents that particular percentile. And this is the same data set from cost in cents to print 1 page of text for 20 printers. So here, part D, we want to find the percentile that represents the 72nd percentile. And then part E is finding the price representing the 58th percentile, and then the 30th percentile for part F. Okay. So here we're going to find the price that represents the 72nd percentile. Okay. So here, we want the data value for the 72nd percentile. And this is where we use the I is equal to P over 100 times N. And by the way, how many data values do we have here? 20. So that N is equal to 20. Take that off to the side. And then we just substitute those values into this formula for finding the position. Here, P is 20 divided by 100. 72. Your P is 72. Your N is 20. So it'll be 72 divided by 100 times 20. So what's 72 divided by 100 times 20? 14.4. Here we came up with a decimal. That means we need to round this up to the next larger whole number. Round it up, 14.4 would be 15. So here we're going to be looking for the 15th number that's in this data set that we have here. So going back to here, what is the 15th number in this data set? 15. It's 5.8 because it's 510. It's the 15th number, 5.8. So in this case here, 5.8 represents the 72nd percentile. Okay. All right, questions on part A. Okay, and this should be D, yeah. This is D. This is E. E is the 58th percentile. So here we're going to find the data value that represents the 58th percentile. So here, that's where we use I is equal to P over 100 times N. This time your P is 58 divided by 100 times N, still 20. So now it's 58 divided by 100 times 20, 11.6. Again, that's a decimal, not a whole number, so we need to round this up to 12. So we need the 12th data value. Okay, so going back to this, the 12th is 5.2. That's the 12th number in that data set. So here, well, 5.2 represents the 58th percentile. questions on that. All right, now part F, here we're going to be looking for the 30th percentile. The 30th percentile. So here we're going to be doing I is equal to P over 100 times N again. This time it'll be 30 divided by 100 times 20. Now what's 30 divided by 100 times 20? This time it's 6. So this time we came up with a whole number of 6. So that means we need to do the 6, we need to find the 6th number and the 7th number and take the average of the two. The 6th and the 7th number divided by 2. So what would be the 6th number in that data set? Okay, the 6 is 3.3 and the 7th is 3.4. I'm going to divide by 2. Okay. So if we figure this out, that's 6.7 divided by 2, or 3.35. So that means that 3.35 represents the 30th percentile. Any questions about problem number 24? Okay, and I split that particular problem into 2 parts. The first 3, A, B, and C, you have to locate actually find the percentile for that particular data value. And then D, E, and F, you have to find the data value that corresponds to that particular percentile. Okay, next we'll look at problem number 8. It says here, Tim, the tire dealer, wants to set the warranty on a particular brand of tires so that 15% of the customers at most return tires because of premature wear. Tim obtains the following representative data on the lifespan of the sample of tires from some of his customers, rounded to the nearest mile. What mileage should Tim guarantee his warranty? Okay. So 15% at most return tires because of premature wear. So here we're dealing with the 15th percentile. All right, in this case here, that's where we use that I is equal to P over 100 times N. And what's your N in this case? Again, 20. Okay, so P is 15, so this is 15 divided by 100 times 20. How much?
3.
It's 3. And that's a whole number. That's a whole number. So that means I need to look at the 3rd and the 4th and get the average of the 2. What is the 3rd number in that data set? And the fourth,
17,400.
and we're going to take the average of the two. Okay.
17,000.
Okay. So this adds up to how much? Well, let's say, well, I know 34,000 divided that by 2, which will be 17,000. Okay. So here, to answer that question, the mileage that Tim should guarantee in his warranty would be 17,000 miles. Okay. That is, if he wants to set the warranty so that 15% at most return their tires because of premature wear. Okay. Any questions about problem number 8? Okay. All right. In this next example that I'm going to show you, this is going to be one way of summarizing data using percentiles, like this one. A teacher recorded the prices of different brands of school supplies. Summarize the data with percentiles in the table. Okay, so here we got cost for markers, for binders, and for paper. Now, here the answers are going to vary when you do this. I don't think this is going to be in the homework, but here they chose to report the 20th and the 80th percentile for each item in the table format. And they're following the procedures that outlined earlier for finding the values that represent the 20th and 80th percentile. Here they have to sort the data set in numerical order for markers, for binder, and for paper. And they use I is equal to P over 100 times N. And then located the number that's in the 20th percentile for each of these supplies, and the 80th percentile for each of these supplies, and the number of observations. That would be N. Because there were 14 prices for markers, 10 prices for binders, and 12 prices for paper. Okay, we're going to look at one of these as an example. Like problem number 25 on page 473. And by the way, another possibility would be to report the 25th, 50th, and 75th percentiles. And in this case, we have a table just like that. And this is problem number 25 on page 473. Pete, the painter, recorded the price per gallon in dollars for samples of 2 types of paint, black and semi-gloss. And here, we want to complete the table. That's going to be part A. And in part B, we want to use that table to answer the question, on average, which type of paint is more expensive? And in part C, which type of paint shows the most variation? So on the left side, you see all the cost per gallon for flat paint and the cost per gallon for semi-gloss paint. Okay. And this right here is the table, part A. I'm going to go ahead and try and reproduce this table that I have up here. So for flat, and then semi-gloss. And this is broken up into 3 groups: the 25th percentile, the 50th percentile, and the 75th percentile. Now, as for observations, let's start with that first. How many prices for flat paint do we have? How much? 24. Okay. So here we're going to put 24 here for flat paint. And what about for semi-gloss? They're 15. All right, now for flat paint, let's start with that. We need the percentile. We need the data value that's in the 25th percentile, the 50th percentile, and the 75th percentile. Okay, so flat paint. And that's where we use I is equal to P over 100 times N. And in this case, your P is 25, so it'll be 25 divided by 100 times the number of observations for flat paint, that's 24. So 25 divided by 100 times times 24 is how much? Is 6. Okay, that's the 6th position. It's an even number, a whole number, so we need to look at the 6th number and the 7th number and get the average of the two. So from that table for flat paint, they're both going to be 15. That's the 6th and the 7th are both 15. Well, that's going to be easy, which means the average is 15. So the number 15 will be the 25th percentile. Okay. And now for the 50th percentile, that would be I is equal to, this time P is going to be 50 divided by 100 times 24. So 50 divided by 100 times 24 is how much? Should come out to be 12. Again, that's an even number, so I need the 12th number and the 13th number and divide by 2. Okay, so here, they're both 18, because that's the 8, 9, 10, 11, 12, and 13. They're both 18. So it's going to end up being 18, because that's 36 over 2, which is 18. So the number 18 is the 50th percentile, which, by the way, is also the median of this data set.
That's 50 over 100, 50 over 100.
Yeah. All right. And then finally, for the 75th percentile with flat gloss, 75 divided by 100 times 24. And that would be how much? $75 divided by 100 times 24. I get 18, which is an even number. So we need the 18th, a whole number. So it's the 18th and the 19th number divided by 2. So the 18th number in this data set is, that's the 16th, the 17th is the 18th, and the 19th, they're both 21. Ends up being 21. Okay, so we got flat gloss taken care of. Now let's look for semi-gloss, the percentiles or the numbers that represent the 25th, the 50th, and the 75th percentile. Okay, let's start with the 25th percentile. Still using P over 100 divided by N, that's 25 over 100 times. How many? Well, the number of observations for semi-gloss is 15. So what's 25 divided by 100 times 15? Okay, 3.75, which rounds up to 4. So we're looking for the 4th number that's in that data set. Okay. So 17, because that's the 4th number in the data set. And then for the 50th percentile, it'd be I is equal to 50 over 100 times 15. This should be 3.75. All right, so what's 50 over 100 times 15? I know that's half, so half of 15, 7.5, rounds up to 8. We need to find the 8th data value that's in that set for semi-gloss paint. It'll be 23. Okay. And then for the 75th percentile, that's I is equal to 75 over 100 times 15. Because I know that's 3/4 times 15. That'd be 11.25. We round that up to 12. So we need the 12th data value that's in semi-gloss paint. It'd be 32. Okay. All right, so that's how we complete that entire table. Any questions about part A? Now in part B, on average, which type of paint is more expensive? Okay, which type of paint is more expensive? Okay, so now let me go back to this table. Now in this case here, I would look at the median to determine which one is more expensive. Because that's the center, the 50th percentile. So which one is more expensive, the flat paint or semi-gloss? Semi-gloss. because the cost there is at the center, that's 23, so that would be something like the average. It's more expensive than flat paint. Okay. And which type of paint shows the most variation? Yeah, semi-gloss as well, and here's why. Take a look at the 75th percentile and the 25th percentile. We call this the inner quartile range, or IQR. Okay, so if you do 32 minus 15, that's 17. Now for a flat paint, if you do 21 minus 15, that's only 6. So here, the type of paint that has the most variation would be semi-gloss. And that's just by looking at the IQR, or the inner quartile range of those two. Okay. All right, any questions about completing this table for problem number 25? Let's see, we're up on page 473. Okay. Next, we'll look at, we'll look at the 5-number summary, because with those quartiles that we got to be talking about, the 25th, the 50th, and the 75th percentile, we can use that to create what they call a 5-number summary. And it is a collection of numbers consisting of the lowest number in that data set, the 25th percentile, the 50th percentile or the median, the 75th percentile, and the highest number. So let's say the lowest number is 15, the 25th percentile is 22, the 50th percentile is 40, the 75th percentile is 45, and the highest number is 130. So here we can report the 5-number summary in list form or in the form of a table. So this is what list form looks like from left to right. The minimum, then 25th percentile, 50th percentile, 75th percentile, and 130. And also you see the table form. All right. Yeah. And of course, the lowest number is the median, the minimum, the 25th percentile, which is called the lower quartile or the first quartile. And what that does is separates the data values from the bottom 25th percentile. I mean, it separates it in a way that 25% of the data values are less than 22 in this case, and the remaining 75% are greater than or equal to 22. And then the 50th percentile, which is another way of saying the median, that would be the middle number of that entire data set. And then the 75th percentile is sometimes called the upper or the third quartile. That separates the bottom 75% from the top 25%. And then your highest number or the maximum number. And it's split in 4 groups so that each group captures 25% of the data. And here on the next slide is an illustration of just that. Here is split in 4 groups where each group captures 25% of the data. Okay. So that's just an illustration of what that 5-number summary looks like if you were to place this on a number line. the distance between the numbers min, Q1, Q2, Q3, and max. Okay, and by the way, that's how they label Q1, Q2, and Q3 as quartiles. Q1 is the first quartile, Q2 is the second quartile, and Q3 is the third quartile. They really do not have to be the same. For example, a possibility would be something like this. The min could be 5, the first quartile is 15, or in the second quartile is 17. Notice how close Q1 and Q2 are. And then Q3 could be something like 57. And then the max could be 100. Okay. And of course, that 5-number summary does have a lot of information that we can get from. So like 25% of the data belongs to each interval. The minimum to Q1 and Q3 to the max. 50% of the data are less than Q2, and 75% of the data are less than Q3. So if I go back to that slide, here's Q2 right here. To the left of it is 50%, and to the right of it is also 50%. Okay, that splits the entire data set in half. And of course, 25% tile, 25% of the data are less than that. 75% of the data are greater than that. And then of course, Q3 separates the bottom 75% from this top 25%. Okay. And approximately half the data belong to the interval Q1 to Q3. Okay, and the typical value is indicated by the median Q2. Now, also the numbers Q1 and Q3 give an indication of the spread or the variation of the data set. Okay, and that's because the interval Q1 to Q3 contains the middle 50% of the data. Now, we do have a definition, which I kind of introduced in that example that I did up here. It's called the interquartile range, or IQR. And that's going to be the difference between the value of the third quartile and the value of the first quartile, Q3 minus Q1. That's the range of the middle 50% of the data. Okay. So the one that I did up here on the board, where I took the 75th percentile and the 25th percentile, those values, I subtracted it, 32 minus 17. 32 minus 17, that should be 15. Yeah. Yeah, 32 minus 17. 75th percentile, which is Q3, minus Q1, 25th percentile. 32 minus 17, that is 15. Okay. Okay, and that's the orange box for the 5-number summary. It contains the lowest number, which is the minimum, the first quartile, Q1, the second quartile, Q2, or the median, third quartile, Q3, and the highest number, the maximum. Okay. Okay. And I think I'm going to have to stop right here. So on Monday, we will talk about the 5-number summary and how to create a 5-number summary from a data set that will be given to you. And then also we'll talk about how to create a box plot from a file number summary, along with the other things like using outliers, finding outliers and creating those outlier box plots. I'll wrap up this particular section. Make sure your signature's on the sign-in sheet before you leave. And you all have a good weekend.